Linear regression model. Linear regression is a machine learning algorithm based on supervised learning. It performs a regression task. Regression models a target prediction value, based on independent variables. It is mostly used for finding out the relationship between variables and forecasting. Different regression models differ based on the kind of relationship between dependent and independent variables they are considering, and the number of independent variables being used. Linear regression performs the task to predict a dependent variable value, y, based on a given independent variable, x. So, this regression technique finds out a linear relationship between x, input, and y, output. Hence, the name is linear regression. Since linear regression shows the linear relationship, which means it finds how the value of the dependent variable is changing according to the value of the independent variable. In the figure above, x, input, is the work experience, and y, output, is the salary of a person. The regression line is the best fit line for our model. Mathematical representation. Mathematically, we can represent a linear regression as y equals a0 plus a1 x plus epsilon. Here, y equals dependent variable, target variable, x equals independent variable, predictor variable, a0 equals intercept of the line, gives an additional degree of freedom. a1 equals linear regression coefficient, scale factor to each input value. Epsilon equals random error. The values for x and y variables are training datasets for linear regression model representation. Types of linear regression. Linear regression can be further divided into two types of the algorithm. 1. Simple linear regression. If a single independent variable is used to predict the value of a numerical dependent variable, then such a linear regression algorithm is called simple linear regression. 2. Multiple linear regression. If more than one independent variable is used to predict the value of a numerical dependent variable, then such a linear regression algorithm is called multiple linear regression. Linear regression line. A linear line showing the relationship between the dependent and independent variables is called a regression line. A regression line can show two types of relationship. 1. Positive linear relationship. If the dependent variable increases on the y-axis, and independent variable increases on x-axis, then such a relationship is termed as a positive linear relationship. 2. Negative linear relationship. If the dependent variable decreases on the y-axis, and independent variable increases on the x-axis, then such a relationship is called a negative linear relationship. Finding the best fit line. When working with linear regression, our main goal is to find the best fit line. That means the error between predicted values and actual values should be minimized. The best fit line will have the least error. The different values for weights, or the coefficient of lines, a0, a1, gives a different line of regression, so we need to calculate the best values for a0 and a1 to find the best fit line. So to calculate this we use cost function. Cost function. The different values for weights, or coefficient of lines, a0, a1, gives the different line of regression, and the cost function is used to estimate the values of the coefficient for the best fit line. Cost function optimizes the regression coefficients or weights. It measures how a linear regression model is performing. We can use the cost function to find the accuracy of the mapping function, which maps the input variable to the output variable. This mapping function is also known as hypothesis function. For linear regression, we use the mean squared error, MSE cost function, which is the average of squared error occurred between the predicted values and actual values. It can be written as, for the above linear equation, MSE can be calculated as where n equals total number of observation, y equals actual value, mxi plus b equals predicted value. Residuals. the distance between the actual value and predicted values is called residual. If the observed points are far from the regression line, then the residual will be high, and so cost function will high. If the scatter points are close to the regression line, then the residual will be small, and hence the cost function. Gradient descent. Gradient descent is used to minimize the MSE, by calculating the gradient of the cost function. A regression model uses gradient descent, to update the coefficients of the line, by reducing the cost function. It is done by a random selection of values of coefficient, and then iteratively update the values to reach the minimum cost function. Gradient descent, GD, is an iterative first-order optimization algorithm, used to find a local minimum, maximum of a given function. Gradient descent is an optimization algorithm, used to find the values of parameters, coefficients, of a function, f, that minimizes a cost function, cost. To find the local minimum of a function, we start with any random point in the graph. The best way to move in the graph is to move along the line. To move in the direction of the line, we need the slope at that particular point, which will give us the direction to move. To find the slope, we take partial derivative of the cost function, with respect to coefficients m and b. Learning rate. The learning rate is a tuning parameter, in an optimization algorithm, that determines the step size at each iteration, while moving toward a minimum of a loss function. The learning rate is a hyperparameter, that controls how much to change the model, in response to the estimated error, each time the model weights are updated. Choosing the learning rate is challenging, as a value too small may result in a long training process, that could get stuck, whereas a value too large may result in learning a suboptimal set of weights too fast, or an unstable training process. To find how much steps to move in the graph, use the below formula. Model performance. The goodness of fit determines how the line of regression fits the set of observations. The process of finding the best model out of various models is called optimization. It can be achieved by below method. 1. R-squared method. R-squared is a statistical method that determines the goodness of fit. It measures the strength of the relationship between the dependent and independent variables on a scale of 0 to 100%. The high value of R-squared determines the less difference between the predicted values and actual values and hence represents a good model. It is also called a coefficient of determination, or coefficient of multiple determination for multiple regression. It can be calculated from the below formula. R-squared is always between 0 and 1. 0 represents a model that does not explain any of the variation in the response variable around its mean. The mean of the dependent variable predicts the dependent variable, as well as the regression model. 1 represents a model that explains all the variation in the response variable around its mean. Assumptions of linear regression. Below are some important assumptions of linear regression. These are some formal checks, while building a linear regression model, which ensures to get the best possible result from the given dataset. 1. Linear relationship. 2. No autocorrelation or independence. 3. No multicollinearity. 4. Homoscedasticity. 5. Normal distribution of error terms.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.